Good day, sir. In this video, we are going to tackle about exception handling as you recently assigned us a project in VLA. By the way, we will be using the VS Code app in this video, so let's start. Okay, so for the first line, we are using import java.io, which contains classes needed for handling input and output I/O operations. In this program, we are using file reader and buffer reader, which are part of java.io. So file reader is used to read files from the storage, and buffer reader helps read text efficiently. The program needs this package because reading files might cause an exception or IOE exception. If the file is missing or unreadable, IOE exception occurs, which we must handle. Without this import, Java would not recognize file reader and buffered reader. It is important to include necessary imports before using classes from other Java packages, since Java does not automatically include Java I/O. We must manually import it. So next is defining a custom exception class, which is this part. So this line defines a new class called myException. The keyword extends exception means that myException inherits properties from Java's built-in exception class. By extending exception or myException becomes a checked exception, meaning it must be handled explicitly. A custom exception is useful when built-in exceptions do not properly describe an error. We use this class to create our own error messages when a specific condition in the program is met. The exception class is part of Java's exception handling system and allows error handling in a structured way. This approach makes debugging easier because we can provide meaningful messages instead of generic Java errors. Without extending exception, myException would just be a normal class and not a valid exception. So this public myException string message is the constructor of the class, which is called when the exception is thrown. It takes a string message as a parameter, which represents the error message for the exception. The server message calls the constructor of the exception class and passes this error message to it. This allows to retrieve the custom error message when the exception is caught. When myException is thrown, Java will automatically store and return the provided message. Using a constructor and a custom exception class makes it more flexible and reusable. We can create different error messages by passing different strings to this constructor. Without this constructor or myException would not store or return any useful information. So next is defining the main class. So in simple terms, this defines the main class, which serves as the main entry point of the Java program. Every Java program needs at least one class, and the main class is where the execution starts. The public keyword means this class can be accessed from other parts of the program. Java allows an object-oriented programming approach where everything must be inside a class, which is this main class. The class name is main, but we could name it anything. For example, program. This class contains methods that will demonstrate exception handling. Inside this class, we define both normal methods, which is check number, and the main method. The main method is special because Java automatically looks for it when running the program.
And the next line, creating the check number method. This method, check number, is responsible for checking whether the given number is negative. It takes an integer parameter number, which the user provides when calling the method. The keyword static means we can call this method without creating an object of main. The return type void means this method does not return any value. The throw new my exception part tells Java that this method might throw a my exception. This is required because my exception is a check exception, meaning it must be declared or handled. If a method throws a check exception, it must either use throw or handle it inside a try-catch block. Without my exception, Java would force us to handle the exception inside this method. This if statement checks whether the given number is negative. If number is less than 0, the method throws new my exception. The throw keyword creates an instance of my exception and stop execution. Number cannot be negative is passed to my exception, which stores and returns it. If the number is valid, 0 or positive, the program prints valid number plus number. This else part only executes if no exception is thrown. Once an exception is thrown, the method immediately stops running and the exception must be caught elsewhere. Without exception handling, the program would crash if a negative number is given. The main method is where program execution begins. Every Java application must have a main method for execution. The static keyword allows Java to run this method without creating an object. The string arguments parameter allows command line arguments to be passed, though unused here. Java automatically looks for public static void mains string arguments to start execution. Without main method, the program would not run. The main method calls other methods and handles exception. Inside this method, we use try-catch blocks to catch and handle exception. Calling check number in a try-catch block. The try block attempts to call check number -5. Since -5 is negative, my exception is thrown. The catch here block catches the exception and prevents the program from stopping. E-point get message retrieves number cannot be negative from my exception. The message is printed to inform the user about the error. Without the catch block, the program would crash when the exception is thrown. Exception handling ensures that the program continues running even when errors occur. This makes the program more user-friendly and robust. In the next line, this try block attempts to open and read test the text. If the file does not exist, I/O exception occurs. The catch blocks catches the exception and print error file not found. Without exception handling, the program would crash if the file is missing. File operations always require handling since files may be missing or inaccessible. This approach ensures the program remains stable. br.close is important to free system resources after reading the file. Using try-catch here prevents unhandled errors.
Okay, so the output of this program is caught exception, number cannot be negative, error, file not found, and error cannot divide by 0. Why did the caught exception number cannot be negative appears? The program starts by calling the method check number -5. Inside the check number, the if condition checks if -5 is negative. Since -5 is less than 0, the program throws a my exception, which is this one. This immediately stops the method execution and control goes to the catch block, which is this block. And the catch block catches the exception and retrieves the message number cannot be negative, which is this one. The program then prints caught exception, which is this one. Caught exception number cannot be negative. This proves that the custom exception or my exception is working correctly. If the number was positive, this message would not appear and the output would be a valid number instead. So next is why did the error file not found appears. Program tries to open test.txt. The file reader, which is this one, the file reader class attempts to read this file from the computer storage. However, the file test.txt does not exist in the directory. Because of this, Java throws an IO exception, meaning the file is missing. Then the catch block catches this error and prevents the program from crashing. Then the error message, which is the error file not found, is printed to inform the user that the file is missing. And then if the file test.txt was present, the program would have read and displayed its contents. So, since the file is missing, this message appears instead of any file content. So, next is, why did the error cannot divide by 0 appears? So, program then attempts to divide 10 by 0. What's this? In simple terms, in mathematics, division by 0 is not possible and Java does not allow it. Because of this, Java throws an arithmetic exception when trying to calculate 10 divided by 0. This stops execution of that part of the program, but since it is inside a try-catch block, the error is handled. The catch block, which is this, catches the arithmetic exception and prevents the program from stopping. Then, the message error cannot divide by 0 is printed to tell the user about the problem. So, if the denominator was a non-zero number, for example 10 divided by 2, the program would have printed the correct result instead. So since division by 0 is an unchecked exception, it does not require the throws keyboard, but it must be handled properly. So the final summary of this overall code is that the program throws 3 exceptions, but all of them are caught by using try-catch blocks, which is these and these. This prevents the program from crashing and allows it to continue executing normally. First, the program detects a negative number and throws a my exception. Second, it fails to find test.txt, so it throws an IO exception. Third, it tries to divide by 0, which causes an arithmetic exception. Since all exceptions are handled, the program prints error messages instead of stopping. The program then exits successfully with return code 0, meaning it handled all errors properly. So overall, this is an example of good exception handling because it always ensures that the program remains user-friendly. So that is it for our video presentation. I hope we were able to discuss and explain exception handling well. Thank you, sir, for taking the time to watch this video, and once again, thank you for watching.